Hi, welcome back. This is Professor Ridge, and today's lesson on section 2.1, increasing, decreasing, and piecewise functions. A function f is said to be increasing on an open interval I if for all a and b in that interval a is less than b implies f of a is less than f of b. So what we're talking about is as you move from left to right, the y values get larger, so the function is going up as you move left to right. So that's increasing. A function f is said to be decreasing on an open interval I if for all a and b in that interval a is less than b implies that f of a is greater than f of b. So again, this says that as you move on a graph, as you move from left to right, the y values, remember these are y values, f of a is greater than fb, that's saying that the y values are going down as you move left to right. A function f is said to be constant on an open interval I if for all a and b in that interval f of a equals f of b. So we're saying all the y values are the same, so it's a horizontal line basically. Right? It's not going up or down. So let's look at it. If this is a, the y coordinate here would be f of a, and b is to the right of a because a is less than b. And again, the idea that f of b is, or f of a is less than f of b, see this would imply that the function's increasing. It's going up as you move left to right. So it's increasing from a to b. Decreasing would look, if you had a right here, this would be f of a, and b is to the right of a still, so we're going from left to right. It would be f of b, and we're going down as you move left to right, so that's decreasing. And then constant, now it doesn't matter which one's on the right or left since they're all going to be equal to each other. So see, it's not going up or down, it's just going sideways. It's a horizontal line. Okay, so that's constant. Yeah, so let's look at an example. Determine the intervals on which the function is increasing, decreasing, and constant. And so if you notice, from -4 to -2, as I move from left to right, it's increasing. It's going up. And also, from 1 to 3, you can see that as I go from left to right, that's also increasing. So from -4 to -2, it's increasing, and from 1 to 3, or I should say or. So it's increasing on -4. And we use, by definition, when we talk about increasing, decreasing, we're talking about open intervals. So we use parentheses, -4 to -2, union, 1 to 3. Okay, B, it's decreasing on, so decreasing, that's going down as you move left to right. So this part right here would be going down from 3 to 5. And constant is not going up or down, just a horizontal line. And that would be this portion right here between -2 and 1. All right, so that's how you would answer those. Relative maxima and minima. Suppose that f is a function for which f of c exists for some c in the domain of f, then f of c is a relative maximum if there exists an open interval I containing c such that f of c is greater than f of x for all x in I, where x is not equal to c. So basically we're just saying that this y value, f of c, is bigger than all other y values in this interval. Okay, in an interval. So, and we're not making any restrictions on how big this interval could be. It could be any size. We just have to find an interval such that we got a greatest y value. So we call that a relative maximum. And what it looks like is that it's a top, a peak, or a top of the hump, top of the hill, however you want to think of that. Okay, now minimum, FC is a relative minimum if there exists an open interval I containing C such that f of c is less than f of x for all x in I where x not equals to c. So again, basically we're saying, can we find an open interval where f of c is the smallest value of all the y values in that interval? So there's some examples of the picture. So for a relative maximum, we're going to look for a peak. See, this is C. This would be f of c. So f of c is a relative maximum because we can find a interval. Say here's an interval from A to B such that f of c is higher than all the x's in that interval. Right? So that's a relative max. Now for a minimum, we're looking for the bottom valley. It's right here. F of c. Here's c. So f of c is a relative minimum. Okay, and again, it's the y value. Is the relative min or max. The x value is where it happens. Okay, so the y value is the relative minimum or maximum, and then the x value is where that relative minimum or maximum occurs. Alright, so we want to find relative minimum and maximums. So if we look at this, so if this is, say, the point -2, -3, so I just want the scale, I'm just going to make it up. And how about 3, 4? So we can say there's a relative minimum at x equals -2, and the relative minimum is equal to -3. Okay, the relative maximum is equal to 4, and it happens at x equals 3. Alright, so again, the y value is the actual maximum or minimum value of the function, the relative maximum or minimum. And again, it's relative because notice, on this picture here, here's 4, and all these water values are higher than 4, so it's not the maximum value for the whole function. Just in a confined area, in an open interval, see that's the top, that's the highest value in the neighborhood, you know, we could say it that way. Okay, so, and again, there's no restriction on how small you're looking at it, so basically you're just looking for a hump or a value for a maximum or minimum. Okay, so that's all we're looking for. Our next topic in this section is piecewise function, and it's precisely that. We're going to define a function in pieces. Let's look at this example. I might say f of x is equal to, and then I use a brace, and I could say 3x plus 1, 4, and I'm telling you the interval, the x values that I'm going to use 3x plus 1. So I might say something like x is less than -3. And then I could say f of x is equal to just x for x is between -3 and 1. And then I could say something like x minus 1 squared for x is greater than or equal to 1. Okay, so what I did is I defined this function into 3 pieces. So if I asked you find the following function values, so that's f of 0. So then the idea is you got to figure out what where is x equals 0? Is it going to be in this interval, or the bottom interval? And x equals 0 falls in this middle one. So that's going to be just 0. That's 0. If I wanted to do f of -5, well, the x value, so again, you look at the where it says 4x is less than -3. Well, that satisfies that condition. So that's the condition to use the top equation. So I'm going to use 3 -5 plus 1. So it's -14. Okay, so you don't plug it into all 3 of them. You plug it into the one that satisfies the condition where x is. So if I did f of 1, that's the bottom one. So I'm going to go 1 minus 1 squared, which is 0 squared, which is 0. If I did f of -3, that would be the middle one, but the equal to for the -3 is in the middle one. So that's just -3. I did f of 5, that's the bottom one, because x is greater than or equal to 1, 5 is in that interval. So I'm going to go 5 minus 1 squared, which is 16. So graph f of x. So to graph this, what I usually do first is I split my x-axis to the intervals. So here's x equals -3, and then it splits at 1, and then okay, so this portion is x is less than -3, so we're going to graph y equals 3x plus 1 at this portion. And so what I normally do is I would graph the line and then just erase the portion that's to the right of that vertical line, x equals 3, this dotted one I put it. Okay, you can't see what I'm doing, so you know the y-intercept's 1, and I'm going to go down. I'm going to go up 3, the right one, or I can go down 3 to the left 1, down 3 to the left 1, down 3 to the left 1. And since this is going to be an open circle here, wait a minute, I messed up, it should be right here. Down 3, left 1, right there, and then I draw the line through that portion. Okay. Now in the middle portion I would graph y equals x. So this portion is from -3, I'm going to do y equals x. So that's going to be -3, 3, and that's a solid dot. -2, 2, 0, 0, 1, 1 is open dot. And then from this portion I'm going to graph y equals x minus 1 in parentheses squared. So that's a parabola that's the vertex is moved to the right 1, and we got the equal to on this one, so that's a solid dot at 1. I go 1, 1, 2, 4. So it's a parabola like that. Okay, so that's a piecewise defined function. And notice I drew the graph in pieces. I did the 3 pieces, and as simple as that. Our next topic is the greatest integer function. This may be new for a lot of you. So f of x is equal to, we make a bracket with an extra line in it, x. This is called the greatest integer function. And it's the greatest integer, this is the way it's defined, the greatest integer that is less than or equal to x. So that's my integer. F of x is the greatest integer of x. Find the following. F of 1 is just 1. F of 2.35 is equal to, so we want the greatest integer that's less than or equal to 2.35. So that's just 2. Okay. So basically on the positive side, it's always going to be, like truncating. You're not rounding. 2.99, the greatest integer of that is still 2. 1.75, the greatest integer is 1. F of 99.999 is not 100. You're not rounding. You're taking the greatest integer that's less than or equal to 99.999. So that would be 99. Now, I use this fancy word called truncating. That's where you just drop everything at decimal. But it's not truncating. It's called the greatest integer. And the reason is when you go on the negative side, you got to be careful here. F of negative 2.3 is actually going to be negative 3. And if you think about the number line, here's negative 2, Here's negative 3. Negative 2.3 is right here, and you want the greatest integer that's less than or equal to negative 2.3. So you have to move back. So you're always moving back to the last integer you passed if you're moving from left to right. So it's the integer back to the left. Okay, so you can't be 2 until you actually hit 2 or pass 2 but haven't got to negative 1 yet. Okay? So you have to be careful. If I asked you to graph f of x equals the greatest integer, okay, so again, 0 would be 0, 1 would be 1, f of 2 would be 2, but 0.5 would go back to 1, so we get this kind of motion, the open circle there. From 1 to 2, the y value would be 1. From 2 to 3, the y value would be 2. So this is called a step function. That's another name for this. Okay. And then you're going to follow this pattern on the left. So negative 1, f of negative 1 is negative 1. And then an open circle at 0. So that's when it jumps up. F of negative 2 is negative 2. And all the way until you get to 1, it's still going to be negative 2. Negative 3, same thing. Negative 4, same thing, and so on. Okay, so again, that's called a step function. That's an alternate name for greatest integer. Well, that's the type of graph it is, because it looks like a stair step. Alright, so that concludes the lesson for 2.1. Go to My Math Lab, make sure you do your exercise there, and I'll see you next time.